Memoization is nothing but storing the subproblem's results into a cache and reusing it whenever it is encountered again. So let me start with this. So I will again create, say, Fibonacci top-down. Okay, and again we'll use the same formula, but let's create a helper function because we will be passing it the memoization array that we're going to have, helper, something like this, and I will pass this, and I will use new, say, because we are using long, and then long n+1. We are using one extra space just for the base condition to hold. And then let me create this new method, long. I will use it as memoization. Now in the memoization technique, as we mentioned, we are going to store the results in this array, in this memo, and then reuse that whenever we encounter the subproblem. So let me just copy this because the base condition will be still same. That if it's 0 or 1, it will just return that value. Now we check first of all, because all the arrays in Java are by default as 0. So if we encounter this, it means that we haven't calculated the we don't have the stored value in our memory in this memo array for this n value. That's why it is 0. So this condition is there, but we have to calculate it again. So how we calculate is the same formula. We just use memo n is equal to helper. Yeah, we call this helper again with n-1, and we pass this memo array with this. Similarly for n-2. And then we simply return the stored cache here. Okay, I think this should be it. So here, what we are doing is that let's go through what we have done. So we, whenever we call this using Fibonacci top-down, using the top-down dynamic programming solution, we create an array which will store the intermediate results into the stored memory. So, and we pass it this as n+1, +1 for the base condition. And then once we reach this function, we are using for the base conditions, we are returning for 0 and 1. It will simply return the same number, 0 or 1. And then we do this condition that whether we have this n value cached into our memo. If it's not cached, it would be still showing as 0, and then we need to recalculate it. So here, what we are doing is that we are only calling this whenever the this Fibonacci number for n is not stored in our cache, and it will be done only once. By doing this, I think we are only calculating this once, and that's why I can say that this should be the time complexity of n, because we are only calculating for a particular n only for once, and we store that into our memo. So let's see how this works with what is the performance with this. Last time we remember that for the recursive solution for 50, it was not even showing up. So let's try this. Oh, so it's very, very fast this time. So for 6 times, I think for the first time, it's just do something like JVM warm up. That's why 277, and then after that, it was having the hotspot. It was so quick that even 50, it's such a less time. So that's the benefit. We can see that it's a tremendous improvement from O of 2 to the power n polynomial to the linear